So what you see on this slide is an example of property of equality for exponential equations. It basically says that if you have the same base on both sides of the equation, then the exponents must be equal. So on the left in this example we have 3 to the x, and on the right we have 3 to the 5th. That means that x must equal 5. Kind of common sense. Let's see what it looks like in a more complicated setup. In this equation we have 9 to the 2x on the left side, and we have 27 to the x minus 1 on the right. So this does not meet the criteria of the slide we were just looking at, because the bases are not the same. We have a base 9 on the left and a base 27 on the right. If we can get them to be the same base, then we can use the property that we just looked at to quickly solve this equation for x. We need to get these to be the same base. So you have to look at a 9 and a 27 and try to figure out that those are both powers of what number? They are both powers of 3. 9 is 3 to the second power. 27 is 3 to the third power. They're both powers of 3, and we need to write them as powers of 3 so that our bases can be the same. So on the left side of this equation, I can write 9 as 3 to the second power, and it already had a 2x on it. And on the right side, I could write 27 as 3 to the third power, and it already had an x minus 1 on it. Let's simplify the left side of the equation to be 3 to the 4x power, and simplify the right side of the equation by distributing this 3. It's going to be 3 to the 3x minus 3 power. Now I have the same base on both sides, and I can use that property of equality to simply say that 4x must equal 3x minus 3. This is a nice linear equation. Solve it like we would have done in chapter 1. These cancel out. 4x minus 3x is a single x, and it equals negative 3. So we have solved the original equation for x. I could plug it back in to check if it is true on both sides. Slightly more complicated because it involves a fraction, but it's the same idea. We need to get both sides to have the same base. Our current bases are 4 and a half, and those are both powers of what number? That's what you need to ask yourself. 4 and 1/2. Those are both powers of 2. 4 is just 2 to the second power, and there was already an x over here. We'll put that outside for now. And on the right, 1/2 is going to be 2 to the negative 1 power. That's how we end up with the 2 on the denominator like that, right? Negative exponents mean fractions. So 1/2 is the same as saying 2 to the negative 1 power, and this already had an x minus 3 on it. Simplify the left side, it's going to be 2 to the 2x. Simplify the right side by distributing this negative 1, so it'll be 2 to the negative x plus 3 power. Now I have the same base on both sides, so I can say exponent equals exponent, and solve this equation for x. Add x to both sides, 3x equals 3, and x equals 1. Second part of this homework assignment is going to jump into this type of equation. Still exponential, the x is still in the exponent. But the issue here is that there's no way you can ever get 4 and 11 to be powers of the same number. There's no way I can get them to be the same base. If you're stuck in a situation like this, you're going to do what it says at the top of the slide. Take a logarithm of each side. So this is the whole purpose of learning logarithms. The whole purpose of learning logs is so that you can solve an equation like this, where you can't get the same base on both sides. So I'm going to write the equation 4 to the x power. Leave myself a little room here in front of the 11. Because what I need to do is take a log on both sides. I have to leave myself enough room to write the log on both sides. I'm going to log this side and log this side so that I keep my equation balanced. Whatever you do to the left, you do to the right. And then based on my properties of logs, which we covered earlier this week, we know that this x can come down in front of the log and be written as a coefficient. So another way of writing this equation now is to have the x in front, the log 4 equals log 11. Both of these logs, by the way, are base 10. I am not showing that, and you never have to show that. You always want to use a log base 10 here because it's the one that all calculators can calculate. Okay, and we're going to use our calculator to get the final step of this problem. To solve this left side of the equation here for x, I just need to divide by this whole log 4 and get rid of it. Okay, divide this side by log 4. These cancel out, and x is going to equal, if I wanted the exact answer, well, that's it right there. There's no way to simplify that fraction. You would leave it as log 11 over log 4. However, I'm going to ask you to take out your calculator and get me the approximate answer, which is going to be a decimal, and you can give me maybe 3 decimal places. So you'll take out your calculator and type in log 11 divided by log 4, hit enter, and give me approximately to the nearest thousand. So approximately 1.730 is what I would get for this one. Taking out my calculator and typing it in. Okay? Let's try one more. This one's a bit longer. There's some stuff we have to do here before we can log both sides. So if you go back to the slide we just did, the first thing I did was leave myself enough room and just log both sides. In this one, I want to make sure that the exponent is by itself first. Then I will log both sides. So that means the first thing I want to do here is move this 7 to the other side. It has nothing to do with the exponent. You might as well move it to the other side. The left will say 4e, the negative 0.3x. The right will say 20. 13 plus 7 is 20. I'm still not ready to log it, because I can still get rid of this 4. This 4 has nothing to do with the exponent either. We might as well divide both sides by 4 and get rid of that. So it'll be e to the negative 0.3x equals 5. All right, there's no way I can get these to have the same base. That's my clue that I'm going to have to log both sides. And because I see e in the problem, e makes me think of using natural log or ln. So that's what I'm going to do to both sides. Rather than a log 10, I'll do an ln of both sides. ln. Just like the problem we did before, this is going to come down and be a coefficient. So we're going to have negative 0.3x normal size now in the front. And then ln e equals ln 5. To get rid of this ln e, well, I could divide both sides by it, or I could just remember the property that the base of an ln is an e, and when I do the same base on the same argument, ln e of e just cancels each other out. This is inverses, basically becomes the number 1. So if you have ever had the ln of e, just get rid of it. Okay, it's not important. Then, my equation says negative 0.3x equals ln 5. And to solve this equation for x, I'm going to divide both sides by negative 0.3. X is approximately, because I'm going to do this on the calculator and get a decimal for an answer. Should use the approximately. Divided by negative 0.3 equals, again, I will give you, or you'll give me up to 3 decimal places to the nearest thousandths place. Right? And that's all you're asked to do on your